So, before I show you how to have Google Sheets find the line of best fit for you in the equation, I get to blow your minds with some changes about the names of things, because we don't call it the line of best fit anymore. It's now called the regression line. And instead of y equals mx plus b, it's now y hat equals a plus bx. Because, well, you know, we've taught you to memorize something, and we're just going to change it slightly so you guys know that it really is the same thing. So we put a hat on y, because any y value we get from this equation is a predicted y value. So the hat just means that it's a predicted y value, not an actual piece of data. And then they switch. We teach you slope-intercept is y equals mx plus b. They switch and put the y-intercept first in the equation. And then, of course, just to make things really interesting, they use b for slope. Which I don't know why. I swear sometimes mathematicians just change things slightly just to say they made something new. And then I was tired when I wrote this, so either that or I thought I really need to hammer home the fact that the line of best fit is now called the regression line, because I needed to tell you that twice. I don't know why I have it repeated. And a regression line describes how a response variable, the y, changes as an explanatory variable, the x, changes. And we often use a regression line to predict y. And now I'm going to show you how to use Google Sheets to get the equation of the regression line, which you don't have to remember all your algebra skills, and we'll all get the same equation instead of her having a slope of 12 and him having a slope of 16. So, if you have your Chromebook, can you please get it out? I feel like the lights turned on and now I can't tell the difference in those colors besides blue.
Oh yeah, they turned off.
It's just Casper, the friendly ghost. And he makes the beeping go off over there. What? I know, why were you texting me in the middle of class? You think it's funny? Yes, you should. Do you not have your Chromebook?
Why, dear?
It what?
I have the beats.
Okay. But you can... He just wants to go to PT with Chance. Alright. How long does it take for the Chromebooks to actually get there? Are we good to go?
About 5 seconds.
You're still loading? Okay. I'll wait. Just another second. So, when I show you this in Google Sheets, there's two ways to do it. They take about the same amount of time, so I'm going to show you both ways, and then you can choose which way you prefer. But they both have more than one step, so they end up taking about the same amount of time. So first thing, we're going to put our data in there. So you're going to put your GPA and ACT scores in. We have 3.0, 3.5, 3.1, 4.0, 3.7, 3.1. And Nate and Joanna, if you haven't put them into the data into your lists already, if you'll do that for me, please. And then ACT. I don't know, can you? Thanks, Chloe. Yes. Hurry up, Tanner. So, Nate and Joanna, yours is actually simpler. You're going to do the exact same thing you did yesterday. Okay? Where you found R, it's also going to give you the equation to the regression line. So just do those same steps and you'll see it'll match ours. So, first way, you're going to highlight your data. I wouldn't highlight the labels. I don't know if it would change anything, but I don't do it because it might. And then you're going to, I'm going to zoom in just a little. There we go. So you're going to go to insert just like we did yesterday. Go down to function, over to statistical. And, oops, too far. Intercept. That's going to get us our y-intercept of our equation. So when I click on it, remember if you need help, you can click on the little question mark and it'll kind of walk you through it. Biggest thing to remember is you have to put the y data first and then the x data. So our y data starts in cell B2 and goes to B7. So B2 colon B7. And then we're going to put a comma and a space. And then we're going to tell it where to find our x data, which is A2 to A7. And then, just like yesterday with R, it puts it in the little thought bubble, but if I hit enter, it'll actually give me my y-intercept in the cell. And I'm going to type y-intercept next to it. Oops. If I actually could. Just so I don't mistake it for something else. Questions? Yes?
Why is the thing negative? Oh, is that the y where it's crossing?
Yeah, where it hits your y-axis. So it's down below 0.
Okay, it's the y.
Yeah. No, you're fine. So then to find the slope, we're going to highlight our data again. Go back to insert, function, statistical, and scroll down until you find slope. And then you're going to choose slope. Same thing as before. You're going to tell it the range for your y data, comma, the range for your x data. Oops, that's not the symbol I wanted. And then when I hit enter, it gives me my slope. If I could type. So we have a slope of 11.5 and a y-intercept of negative 15.1. Any questions? Okay, so that's one way you can do it. Did you say yes and I thought you said no? Sorry, I thought you said no.
What is this? No.
Oh, you have your X and your Y.
Oh, look at that.
So you have to. Comma space.
Feels so good.
There you go. I don't know why Google Sheets makes me do the Y first. Okay. Any other questions?
I got preceded second in the state wrestling.
Really? Yeah.
Yeah, so I'm actually wrestling this year and I'm gonna kill myself.
You actually would?
Please tell me you don't have to cut weight.
Well, I mean, I'm not gonna purposely cut weight.
This is the
Is that right?
most unhealthy thing
Well-
about wrestling.
What, like, on Saturday I weighed 194 and like right now I weigh 187 and I have to wrestle 182.
So
So,
with wrestling though, like I wrestled for 2 weeks, and in that 2 weeks, like I wasn't trying to cut weight. But
yeah, no, you just
you
lose
just
weight.
cut weight. Because you wear sweats all the time, it's so awesome.
Yeah.
You feel
Just because like football I gained about like 25 pounds for wrestling.
Well, but aren't you being physically active during football?
Well, kind
No.
of. No.
Okay. Okay. I don't know that I struggle with wrestling because of the having to make weight and all that.
Well, it's not very fun.
No, it's not. And you can tell the wrestlers that really have to cut a lot of weight, their face changes. They like get really like horrible bags below their eyes because they're trying to lose so much weight. It's not healthy. I don't think you guys should have like to have to make weight unless you go wrestle in college.
I've never cut weight. I just wrestled wherever I wrestled. Like last year I weighed 180.
But don't you have to stay in the same weight class the whole season?
No.
You don't?
No, like
Well,
freshman year, I started out wrestling 160, and at the end of the year, as districts, I wrestled 135.
So, okay. I thought you had to stay at the same weight class.
Sometimes you do.
Because
Just if
otherwise,
you're-
how
well,
could
if you're
you
really-
qualify for state?
If you have to wrestle the same weight class 2 weeks, and the season's like 3 months long, 4 months long.
Okay.
Yeah, it's
All right. So the other way to get your regression line is to make your graph. So I included the labels this time. And we're going to go to Insert Chart. And then, so it automatically made it a scatter plot for me. I'm going to go to Customize. I'm going to change the x-axis just because it bugs me. So I'm going to put the minimum at 0, max at 4. Because GPA goes from 0 to 4. Oops. I'm going to get rid of this too. There we go. And then if you go into Series and you scroll down, there's an option for the trend line. And you're going to click it, and it'll draw the line of best fit for you. And then if you scroll down, the label default is set to none. You're going to click that drop-down menu and tell it to use the equation. And it gives you the equation up here. So 11.5x, so 11.5 is your slope, plus negative 15.1, which was our y-intercept. So, like I said, they both have 2 steps. The other one, you just do your slope and your y-intercept. This one, you have to make the graph to get the trend line, to get the equation. So I think they take about the same amount of time. So whichever one you prefer, go ahead and use. Any questions before I move back to the paper? No? Okay. So we're going to break down our equation. Y hat equals negative 15.1 plus 11.5 x. So this question here says, what is the slope of the regression line? So slope, remember, is the one in front of x. So our slope is 11.5. Now, would you guys agree with me that I can rewrite 11.5 over 1, and those are really the same number? Okay. The whole reason I do this is when we interpret, it's nice to see a number on the bottom for the number that represents my x. So slope is y over x. Y is ACT scores. X is GPA. Now you don't have to actually put those there. They just help me when I'm formulating my sentence. So I start on the bottom. As GPA increases by 1 point, ACT scores should increase by 11.5 points. That's what our slope is telling us. So as GPA increases by 1 point, we expect ACT scores to go up by 11.5 points. And again, you guys probably better English than me, so you might have a prettier way to say it. But notice how putting the 1 there and my labels, I was able to go, okay, GPA goes up 1, ACT goes up that many. Obviously, if it was a negative slope, the bottom would still go up. But I would say as GPA goes up 1 point, I expect ACT scores to drop because it would be negative. Okay. Any questions before we interpret our y-intercept? All right, so what is the y-intercept? The y-intercept is negative 15.1. And remember, y-intercepts are on the y-axis, so they're when x is 0. So we're going to talk about x being 0, and in this case our x is GPA. So we're going to say something like when a student has a GPA of 0, which is highly unlikely, I'm sure some kid maybe sometime has done it, we would expect their ACT score to be negative 15.1. I can't remember how I said that, how I started it. When a student has a GPA of 0, we'd predict their ACT score to be negative 15.1. obviously you can't get an ACT score of negative 15.1. But like I said, a 0 GPA would be, I suppose some kids do it. I've never had a student who had a 0 GPA.
At that point, it's just impressive of how determined you have to be to get a 0 GPA.
My brother did it in college.
What?
He went to OIT. He wanted to study software engineering. He's 2.5 years older than me, so he'll be 37 in May. 37, yeah. And his first term there. So my parents, they were nice and they saved money for each of us 3 kids to go to college. It wasn't enough to cover everything, but they helped us some. And so his first term, they paid for it, and he passed one of his classes. And they told him that they'd pay for one more term, and if he could pass all his classes, they'd keep paying. But if he failed the majority of them, they'd stop paying. So that my brother, the next term, brilliant kid he is, he failed every class instead of improving his grades. And they said, okay, you're on your own for college. And he still hasn't finished college. He's going. He takes one class maybe once a year.
What is he going to do?
Well, right now, I don't think he has a job currently. He was working at OHSU. Nothing special. He would deliver the meals to the patients.
This is what this picture of the same burger chat.
I didn't need to see that. And then he went to bartending school. I didn't even know there was a school for bartending.
Yeah.
But because of the pandemic, nobody's hiring bartenders. His girlfriend's a pharmacist. So he's really lucky he gets to just kind of hang out at home right now.
Yeah.
So, actually, I wouldn't say lucky. I could not stay home. I am not a stay-at-home person. All right, so now we're going to use our equation to predict ACT scores from a student with a GPA of 3.4 and a student with a GPA of 4.4. And yes, GPAs of 4.4 happen at schools where they weight GPA. We don't weight them here at North. So we have y hat. That tells us it's a predicted y value. I'm going to do a little subscript to 3.4 so that I know I'm making a prediction of a ACT score from a 3.4 GPA. And then I have negative 15.1 plus 11.5 times 3.4. $11.5 times 3.4, and then I'm going to add negative 15.1. So we would predict an ACT score of 24 for a student with a GPA of 3.4. Questions on that part? All right. And then here we're going to predict the ACT score for a student with a GPA of 4.4. So same thing except for you put 4.4 in for X. Of course you do, Tanner. You are so welcome. I'm sure you're really happy I remembered to give you the homework assignment. So 11.5 times 4.4, and then we add negative 15.1. So we predict an ACT score of 35.5. So almost somewhere, because I know they don't give half scores. So 35, 36. Almost a perfect score, possibly a perfect score. Now, when it comes to regression lines, there's this wonderful thing called extrapolation. And I put it down at the bottom here. So when using a regression line to make a prediction outside of the interval of values of the explanatory variable x, it's called extrapolation, and it's often inaccurate. So what this phrase means that I highlighted, if we go back to our original data, GPA is our x, or our explanatory, and my lowest GPA is 3.0 and my highest GPA is 4.0. So if I plug in a GPA between 3 and 4, my regression line is going to be a good predictor of the actual ACT score. If I plug in a GPA below 3 or above 4, it's not going to do a good job. It's going to usually be inaccurate because I'm extrapolating outside my interval of my x values. So here, 3.4 is between 3 and 4. So this is a good predictor of the ACT score for a student with 3.4 GPA. 4.4 is outside my original values of x, so this is an extrapolation, and it's probably not very accurate. And I can promise I will have 1, probably 2, maybe 3 questions about extrapolation on your test. I'm leaning towards 2 right now. But so it is an important thing. Questions? No. All right. So last period I tried to have them do this one. And they didn't get very far, I think, because it's a weird graph. So why don't you guys look at the exit task? Because honestly, once you make the graph, then I was just going to have you find the regression line, identify your slope and y-intercept, interpret, and then talk about 2 predictions. Well, it's the same thing I have down here. And since that's a weird set of data, why don't you just look at this bottom one? The only nice thing is you don't have. Did you get any good information?